Okay, so this week we're going to do transformer. So log on to Canvas, go to the lab menu activity and click on lab 10 transformer. Okay, and once you do that, let me bring up the file. So hold on. Let me share my screen transformer. Okay, so what is a transformer? We use that every day because when you have a power generation, when you have the when the power is generated from the power plant, it needs to be transmitted to the household. And when the power plant generate, electricity, it has high power, it has high voltage or high current. How do you transmit those power to the household safely? So so based on Faraday's law of induction, it's found that there's a way to do it. So you can we can have a device which is called the AC transformer that can raise or lower the voltage and current without causing appreciable change in the power. The product is current times V power. Okay, so you can see that a transformer is a very useful device that you can adjust, you can lower and raise the current and voltage, but without sacrificing, without much loss to the power IV, which is the one that we want. Okay, um, so experimentally, this is conceptually this is how it works. So let's say you have a soft iron and you have you have the you have the circuit, wrap around or coil that wrap around the soap irons on the left side and on the right hand side. So on the left hand side, when this is the input power, we call that primary, and on the left hand side, when this is the output, we call that secondary. So you can see that we can just adjust the output voltage and current by changing the ratio of the coil, the number of coils on the primary and on the secondary. And the equation, so when you use the Faraday's law of induction, you'll be able to deduce equation one, which says the MP, which is the number of coils of the primary times the voltage of the secondary, is equal to the number of coils on the secondary times the voltage of the primary. Okay, so in other words, based on Faraday's law of induction, MPVS is equal to NSVP, and so you can see that. So then it becomes just very simple. If you want to raise the output voltage, you just increase the number of coils. In other words, the secondary, then the NS has to be greater than NP in order for VS to be greater than VP, and vice versa. So in other words, if you have if you want to lower the VS, then you just use a smaller value for NS compared to NP. Okay, so in other words, the ratio of the number of coil determine the relationship between the voltage of the outputs of the input. And likewise, based on the same load induction, the current can also be raised or lowered. And when it is being after derivation, this we'll get the equation two, which is the MP, which is the number of coils on the primary times the current through the through the primary coil is equal to NS times IS. So you can see that based on this, if you want to lower the current, if you want to have a lower value for IS, then you will use a larger number of coil for the secondary. Okay, so when you want to change the current value, then this is what we call the current transformer. And when you want to change the voltage, then we have the what we call the step up or step down. What we call step up, meaning that the output voltage is greater than the input voltage. And when you have a step down, it means that when you have the you have the smaller secondary voltage than the primary voltage. Okay, so equation 1 and 2 will basically tells you without even changing, without you can just changing the ratio of the number of coils, then that pretty much tells you how the output voltage in relation to the input voltage and also for the current as well. Okay, so the basic idea, the basic principle idea is behind that. And experimentally, we would have two coils, and we have the soft iron. And then so this is on the left, this is the primary coil, and on the right, that's the secondary coil. So you can see that for the step up or step down, transformer, we would provide a power source to the primary, and we're going to use a voltmeter to measure the voltage, and we're going to measure the voltage on the secondary using another voltmeter. And we're going to we're going to start with the 0 voltage and then increase in 0.5 increment until we get to 10 volts, and then we're going to compare the input and output voltage to see to see how the ratio and then compared to the number of coils. So for the step up, you would have the 400 for the primary, and you will have the 800 for the secondary, and then you'll be able to deduce how the voltage ratio in relation to the coil ratio. Okay, and it is important. So you might wonder, why do we have to have an iron? Because the iron basically strengthens the magnetic field. Magnetic field generated by the current through the coil. If you remember, when the current goes through the coil, it's going to produce a magnetic field, and that magnetic field, what you have here, how does the magnetic field induce a magnetic field in here? Then you would need some sort of linkage, and that linkage is through the magnetic flux linkage. Okay, so you have to form a closed loop, so the iron bar has to be closed at all time in order for magnetic flux to be linked, from this point to that point. If the crossbar is not closed, then the magnetic flux linkage will be broken. So in that case, you would not expect the transformer to work. The transformer has to will work only when the crossbar is actually closed, so that magnetic flux will be formed in one continuous form. Okay. And for the current so for the step down, of course, we just replace the 800 coil with the 200 coil, and that's 200. So that, this is 400 on the left and this is 200 on the right. So you get a step down transformer. And for current transformer, then we have to make some adjustment. So instead of measuring voltage, we will be measuring current, and you will have the power source that is on the input. And because we're going to measure current, so the emitter is inserted in the circuit, so it's part of the circuit. And as you can see, this is a series connection. And then on the right, in order to measure the current, we have to have a load. And so we use a small resistor and then measure the current through that. So you'll be able to deduce the IS on the right and IP on the left. And so the NS, so the MP on the left will be 400, remain 400, and on the right, the NS, I think we're using, so let me see which one we're using. For the current transformer, we are using, let me see. For current transformer, we are using 800, okay? And so this is 400 and this is 800, and we're going to, so this basically, we're going to lower the current. And so the data, so after you have the, so you'll be given the data, and you are going to plot, for the step up and step down, you're going to plot VS versus VP. In other words, VS will be on the vertical, and VP will be on the X value. you're going to generate two plots for the one for the step up, one for the step down transformer, and then do a line fit, to get the slope. And then so remember to to provide a figure caption for each figure that you generate. And then you're going to draw, you're going to use the for the current transformer, you're going to plot IS versus IP. So you're going to plot IS versus IP, and the slope. The slope is going to give you, of course, the IS over IP. And then you're going to come, and then from the slope, this data will be given, and then you need to fill out the stuff on this page. So NS over NP, because you're given the numbers for each coil, so you'll be able to deduce that. And then from equation 1, you'll be able to deduce theoretical value of VS2 VP, and the experimental value will be from the slope. So you can compare, so you can get the percent error. Do the same thing for the step down. And for the current transformer, you are given NS and NP, so you can calculate the ratio. And theoretical value, you will be using, I think, equation 2. And the experimental value, you're going to get it from the slope, and then you can calculate the percent error. Okay, so this is basically what you're going to do, and the data. So let me bring up the data. So the data is in a Word document. So you are given the data, and it is from, you have the step up, transformer, step down, and current, and you have all these values. So you need to key in those values to the Excel, and then work from there. Okay, so altogether you should have 3 figures, one for each scenario, and then remember to have the figure caption for each one. And there's a one question in the analysis, so don't forget to answer the question in the analysis. Okay, alrighty.